with SQ4, solving quadratics number 4. We've been through 3 of them. Solving with difference 2 squares, solving a quadratic that has 1 for the first term, and solving by grouping. So now we're going to back up to trinomials again, only we're going to be looking at the ones where the leading coefficient is not equal to 1. Now what does that mean? When you have your quadratic in standard form, and standard form means in order according to exponents, they should be descending, like 2, 1, nothing. And when the first term has no coefficient, it's the understood 1. So these are going to be where your leading coefficient is larger than that. It's a number other than 1. It could be 0.5. It doesn't have to be larger than 1. It could be 0.5. Anyway, you have something in front of your x term. Well, that's a whole different scenario there. When I was in school, we used to use something called the trial and error method, and that was a nightmare. So this may be harder to wrap your head around, but it works a lot faster. Now, what you want to do once you've analyzed your problem, I do have a trinomial, it is quadratic, I need to factor. Since I have a number here, I must use the AC method. So you're going to pick the A and the C out of here, which is this and this. This is A, this is B, this is C. First thing you're going to do is multiply the A times the C. So I'm going to take 2 times 12 and get 24. Now there's some parts of this that are fixing to look familiar to you from the factoring by grouping and the easy method, and they are familiar, but be careful, they're not the same. They're not the same at all. We're going to make a chart under 24 of all the numbers that multiply to give us 24, just like we did in the other one. And go in order so you don't lose anything. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Well, then you start going back with 6 times 4, so you can stop there. You want to pick the pair that adds up to give you this middle term. Now, which numbers add up to be 11? 3 and 8. Okay, that's where it stops being like the easy method because we're not done. What we're fixing to do is we are going to create a situation here where we can use factoring by grouping. What did you need to factor by grouping? You needed 4 terms. I only have 3. But if I take one of these terms and I turn it into 2 terms, then I can factor by grouping. So that's exactly what I'm fixing to do. I'm going to rewrite this expression. Instead of 11x, I'm going to put 3x plus 8x. See, 3x plus 8x is equal to 11x, but when I split them, I now have a 4-term polynomial that I can factor by grouping, just like I did in the last video. Alright, I've grouped them. My greatest common factor here is x. So I have 2x plus 3 left. My greatest common factor here is 4. Don't forget that plus sign. 4 times 2x plus 3. And notice, just like I told you last time, these 2 sets of parentheses have to match when you factor by grouping, otherwise you can't go any further. So next I'm going to pull out the 2x plus 3. And I'm going to put the x plus 4 as my other factor. And I'm going to check these 2. There's no common factors and there is no difference 2 squares, so I'm finished. So this would be your final answer. Okay? Let's work another one. Okay, here's another problem. Now, listen to the analysis that I'm doing in my head. I know I need to factor this. So, is it a quadratic? Yes, because it has this exponent. Next, how can I factor it? Well, count your terms. 1, 2, 3. If you have 3 terms, you have 2 possibilities. You might be factoring with the EZ method or the AC method. If you don't have a coefficient in front of this, and you need to check, be sure that there's no greatest common factor, and there's not. So I'm stuck with this number. Now, when I look at this, I know I can't use EZ because of the 8. I'm going to have to go with AC. And the minute I hear AC method, I know that means multiply my A term and my C term. Okay? So 8 times 5 is going to give me 40. Now remember, our goal here is to create a 4-term polynomial out of this 3-term polynomial. And I'm going to do that by splitting this 14. So let's get our factors of 40 here. I've got 1 times 40, 2 times 20, 3 won't go, 4 times 10, 5 times 8, and that's it. Now which pair adds up to give me 14? 4 and 10. Now you have to watch this one because this is a negative 14. So what does that mean about my pair? Well, it has to be negative 4 and negative 10. Okay? So when I rewrite this, 8x squared, I'm going to put minus 4x minus 10x plus 5. I just split that middle term into two numbers, add or subtract, combine together that are equal. Now I'm ready to factor by grouping. So when I hear that word grouping in my head, I know I'm going to group first two and last two and take out greatest common factors. The greatest common factor here is going to be 4x. So I've got 2x minus 1 left. Now, don't forget, when this is a minus and you're factoring by grouping, it's going to change this sign. Okay? You got to watch for that. The greatest common factor between these two is 5. So I'm going to have 2x left. This sign changes, and that'll be 1. Now, just like I told you before, over and over, that has to match, and it does. So that's going to be my next factor, 2x minus 1 times 4x minus 5. Check these to be sure there's not something else to factor, but otherwise you are finished. Okay? That's all about factoring these quadratics. The next thing we're going to do in the next lesson is we're going to take this factoring and we're going to use it to solve an equation. See, we haven't had any equations. All we've had is expressions. What do you need for an equation? You need an equal sign. So in the next lesson, we're going to be looking at some equations. We're going to use this to solve them, and then we will actually get an answer. Okay? See you in the next one. Bye.